Hello there. In this tutorial, I'm going to discuss about TCP/IP model. So TCP/IP model tran is known as transmission control internet protocol model. In some documentation, this model is also known as SUIT. So transmission control protocol internet protocol model is the basic communication protocol used by internet. It also used for communication in a private network such as internet, intranet, or extranet. TCP/IP is two-layer protocol. So what we do actually, when you compare OSI model with this TCP/IP model, you will find one thing that like OSI model is not a conceptual model. It's practically a known model, and the popularity of TCP/IP model is so much that nowadays almost all vendors is using this model for internet access. This is the standard model now. This is the standard model for internet connection. Almost all the vendors using this model, and so much popular. OSI model is a conceptual model, it's a 7-layer model, but TCP/IP model is not a conceptual model, and it having 4 layers. The higher layer TCP protocol divides the message into a smaller packages called as segments and transmits those segments over the network. This higher layer is actually whenever we provide data via application. uh, you can see here represent data to the user plus encoding and data control. It's almost same like OSI models. Application layer transport supports communication between diverse devices across the diverse networks. So it basically divides the masses into a smaller packets called segments and transmits those segments over the network. That whatever, if for example if you have a 1 GB file, then it will divide into segments, it will divide into paths, and by those paths will be send those paths into the network. These packets are then received by the TCP layer of the other machine. Similarly, the other machine will be received the segments like that. The lower layer IP protocol manages the addressing part of the packet so that they will reach the correct destination. Each router uses these network checks these addresses to determine where to forward these packets. So the lower level is basically uh, took the responsibility for communication, find the internet and network access, and they will know where to send. They will know where to uh, receive data, so they know uh, what to send and how to send, what are the correct path, where uh, to reach those places, so they assign the best possible path. Now actually this is the the 4-layer model. The popularity of TCP/IP model is so much that almost all vendor is using this model, uh, and it's a practical model. Actually, this model start from DoD. It's actually known as DoD model, and this is actually known as DoD model, and DoD model, and Department of Defense in US actually bought this concept. They decide and they actually make out the list how to communicate with computers, how to access different computers with same attitude, with same credentials, with same security related checks. They list out all security related checks, and they conclude this model, and this TCP/IP model came from that DoD model, Defense of the Department of Defense of US, that this model is actually applicable, that a user is accessing a particular application, if sent the data via transport layer, then the network and the network access have to decide where to send this data, and how to send the data, and what are the way to send data, and the end device, how that end device behaves. So they conclude not many things, and they finally made this TCP/IP model. In some of the communication, TCP model known as 5-layer thing, the MAC address and physical layers are combined the lowest 2 layers. So uh, since this network layer, actually, let me show what these layer are. Yes, uh, when we discuss about the TCP/IP versus OSI, we will discuss more about it. But this the network access means data link of OSI and physical of OSI. This network layer means data layer of data link layer of OSI and physical layer of OSI, this network access. So some of the documentation says that MAC address and physical layers are combined, means they actually devise data link layer to one of the layer, and physical layer and MAC address one of the layer. So they divide like that. So application transport, internet data link, and then this physical and MAC. So they divide like that. So okay, so we have to cover the first we cover will be network access. Let me go to another page. Okay, this network access layer. So things to cover at network layer access is internet layer. Okay, so this let me show you. Okay, this network access layer is divided into the 5. So network access layer is the lowest layer of the TCP/IP protocol stack. It's also known as stack. Is the network access layer. The network access layer contains 2 sublayers: the media access control sublayer and the physical sublayer. So as we all say that in some of the documentation, this physical layer and uh, the MAC address layer uh, is known as network access layer, physical and MAC. But actually, at the at the very much concept is there in almost all documentation, this network access layer known as data link and physical, data link and physical. But some of the documentation says physical and MAC is network access layer, and this data is a different thing. So okay, the MAC sublayer aligns closely with the data link layer of the OSI model, and sometimes referred by that name. So that physical sublayer align with the physical layer of the OSI model. So either you consider data link layer, or you consider MAC, or if data is there separately, then you can take that as well. As so it's almost, because it's as a documentation, it's about what documentation is all about, so you have to for that. So now the second thing we have to cover is internet layer. Okay, so internet layer having a couple of things to do, and that is, first is Inter-Networking Protocol, IP. It's very, we all know IP. IP is a transmission mechanism used by TCP/IP protocol. IP is a connectionless and unreliable datagram protocol and provides no error checking. So we all know when we tries to ping some website, we just send packets, but we never get and we never receive. And if that website not working, if our internet connection having problem, and if the packet's not reaching to the destination, then it will never uh, is never provide us correct details that whether it's reaching or not. Sometime might be cache giving us a reply. So it's a connectionless thing, and it's also unreliable datagram protocol. Provides no error checking, means if we are getting a request or if we are getting reply from a untrusted thing, that uh, we have to consider like that. IP transfers data in the form of packets called as datagrams. Datagram can travel through various routes which the destination may not arrive in the order in which they were sent. For example, if I send 4 request packets, 1, 2, 3, doesn't matter, they reach in a sequence. For example, a sender computer send packets like that, so it doesn't matter that these reaches in a sequence. For example, when the during time to send 1 packet, line was down, so they sent 2. During 3, line was down, so they sent 4. When they decide to send 1, that time also line was down, so they sent 3. Then at last they send 1, so it will be sent like that. So it will be unreliable, and doesn't matter that we will send sequentially, because they send like that. They see whether that network is available or not. Also, IP does not keep a track to the routes of the data. Again, they just believe to send packets and nothing else. They don't believe to keep the record, and IP does not record the data once they reach the destination. They does not do a reorder, but they just send data like that. If line is clear, they will send the data like that. Now, ARP, Average Resolution Protocol. Now, ARP is very unique thing. What ARP is, that, oops, okay. So via ARP, via IP address, you can get the MAC address of a computer. This is what ARP is all about. We all already learned about the ARP in a video where we used IP address to track the MAC address. Otherwise, uh, you can find out the MAC address of your own computer, but your native computers, on your network computers, it's very hard to find out the MAC address. So address resolution protocol will allow you via IP address to find out your MAC address. Similarly, there is another thing is another rule is there, reverse address resolution protocol. This is RARP, RARP. Now RARP means via MAC address. If you know the MAC address of some computer, you're able to get the IP address. So it's very hard to know the MAC address, and this is not a conventional thing. RARP is not even popular enough because of this complicacy. Okay, Now another thing which we are discussing about the ICMP. Now this protocol is for the computer interface to send notification of data rate protocols such as query and error reporting messages back to the sending device. It's only function to report the problems to the original sender, not to correct them. Ping command is an example of ICMP protocol. So what exactly we do when we use ping and when we tries to uh, send the packets to our native network, it only tell us whether the line is up or line is down. It only provide the details. It doesn't bother. It just it only tell us that yes, line is clear, your data is reachable, and packets are sending successfully. If line is not clear, then it only give us an error that line is down and packets are not sending, but it never bother to correct them. That's an example of ICMP. That that ping is the example of ICMP. That we just send, we just communicate, we just send packets to our network, and it only provides us that your package is reachable or not correcting them. Okay, another thing is IGMP, Internet Group Message Protocol, like Internet Controlled Message Protocol ICMP. It's a different thing. IGMP. This protocol is used for multitasking, means to transfer message to a multiple recipient at the same time. IGMP, Internet Group Message Protocol, like SMS, when you send data, when you send message to multiple users as a group, like a hangout or any other thing, any other message you sending those uh, simultaneously to many users. So class D IP address is used for this protocol. Now another layer we're going to learn is transport layer. Transport layer. Now the first layer we know to learn is use user datagram protocol, which is UDP. It's an old method to use internet, and it's a connection-less, stateless, and unreliable transport protocol. It adds port addresses and error control information to the data, delivers to the data. It's fast compared to TCP. So UDP basically work on port numbers. For example, HTTP uh, is 80 and the FTP is 21. So it's just believes and it only works on port numbers. So this is what the UDP is there. Uh, it's unreliable thing. That's the reason why it's nowadays not usable. Now the another thing which I'm just wants to tell is transmission control protocol in this transport layer, which is the rule is all about. It's connection oriented and reliable transport protocol. It's very much reliable. It divides data into segments, each having a sequence numbers. These sequence numbers are useful at the receiving end to rearrange the segments into original order. So it's almost a great deal, like it just send data, and also that one having, for example, this 2 3 4 packets having a sequence like 1 2 3, and for example this the packets reach on a user computer uh, one after one, so it having a sequence so that it get rearranged before user able to use that. So basic difference of TCP UDP are: TCP connection oriented, reliable, more payload, slow, send data sequentially. Examples are SMTP, HTTP, and FTP. UDP connectionless, unreliable, less payload, fast, sends data randomly. Examples are DNS, TFTP, and VoIP. So all VoIP app like WhatsApp, Line, Hike is examples of UDP. Now, stream control transmission protocol is reliable and connection-oriented transport protocol that offers acknowledged error-free and non-duplicated transmission of multiple streams of data. Unlike TCP, SCTP makes sure that multiple streams of data will be transmitted simultaneously. SCTP can be used to manage connections over wireless network and transmission of the multimedia. Uh, it supports new applications such as voice over the internet, combines the best features of UDP and TCP. So SCTP is combine the features of UDP and TCP, and nowadays all the voice over the internet application are working on this SCTP only. Now the next layer we're going to learn about is application layer. So SCTP is a very connection-oriented transport protocol and offers acknowledged error-free and non-duplicate transmissions of multiple streams of data. So it's a very reliable thing. Now the next layer, the last layer we are going to learn is application layer. Application. Okay. So application have first features which we're going to discuss is SMTP, Simple Mail Transfer Protocol. It's a protocol used to transfer email messages across the network and the internet. It helps to sending messages such as text or message with attachment to a single or multiple recipient. Another feature we're going to learn is FTP, File Transfer Protocol. We really learn is used to exchange files from one host to another connected over the internet. Server and client are involved process of transferring files. So downloading, uploading via FTP we already done. TFTP is the old version, worked on UDP. DNS, it used to store and resolve the internet domain names of host to the IP address. It's domain name system, domain names of host to IP addresses. Another feature we're going to learn is SNMP, Simple Network Management Protocol. It is used to manage and control network devices, performance and security to the network. It is based on client server model. You find the interesting thing is client server is the configuration of computer network that includes a server and one more client. Another thing we're going to learn is network file system allows computer on different operating system. Example: Windows to Linux, Linux to Windows, Unix to Windows, to share files and the storage. So allows computer on different operating systems. NFS, network file systems. So the another thing we're going to learn is Trivial File Transfer Protocol. TFTP is older version of FTP. It works on UDP, uses UDP to upload or download files, a simple form of FTP, and does not provide security features. So this is what the TCP/IP model is all about, and a couple of features are involved in all these layers. These have this is where the working are. This is how these layers are depending of each other. This is how the packets transfer between the system. So it's very much a practical model and not a conceptual like OSI. In next video we will learn about OSI model versus TCP model, and we'll see how it's going to work and how it's different with each other. So hope you learned something from this video.